can see on your screen, we're going to be learning all about the upcoming program here at Carnegie Mellon University School of Computer Science. This program is in artificial intelligence. Learn practical methods for solving problems with AI. As we make our way through this next hour together, a couple of quick announcements. Firstly, we're going to be touching on two key themes here today, both what is in this program as well as how is this program delivered. So those are the two areas that we're going to be touching on. You're going to learn all about the curriculum and what you can expect to learn. You're also going to be seeing how that course is delivered, what that learning experience is like. So as we make our way through the session, we are recording everything here, and we're going to be following up within 24 to 48 hours to provide you all with copies, not only of the recording, but all of the slides that we cover here as well. So some of the slides have a lot of content, a lot of information, graphs, images. Rest assured you'll be able to come back and take a more detailed look at all of the material that we cover today. So here's our agenda today. We're going to start off by introducing the speakers. You're going to learn a little bit more about this community that you're joining here at Carnegie Mellon School of Computer Science. From there, you'll learn about your program faculty, and I'll hand it over to them to tell you more about the curriculum. We'll talk about next steps. We'll talk about your learning experience. And then as promised there, we're going to save time at the end for all of your questions. So a lot of opportunity for you to learn all about this program. We want to hear from you. We want to know who we have in the room with us and what's on your mind. So let's go ahead now. We have a lot to cover here today. And first and foremost, I want to invite today's keynote subject matter experts and course faculty to say hello. Greet the audience here today. Firstly, we're joined here by Reed Simmons, who's a research professor and director of the Bachelor of Science in Artificial Intelligence at Carnegie Mellon University School of Computer Science. Professor Simmons, would you like to jump in and say hello?
Yes, I'd like to say hello to all the participants here. I've been doing artificial intelligence for 40 years and robotics for about 35 years. I am very much interested in both aspects of symbolic artificial intelligence, probabilistic artificial intelligence, and machine learning, and especially how they all apply to autonomous systems.
Thank you, Professor Simmons, for being here with us today. That's a taste of what's to come. We're going to hear more from Professor Simmons here shortly. He's joined by his co-creator and colleague, Stephanie Rosenthal. Professor Rosenthal is an assistant teaching professor at Carnegie Mellon University School of Computer Science. Professor Rosenthal, would you like to jump in as well and say hello?
Sure. Hi, everybody. My name is Stephanie Rosenthal. I have been doing AI for close to about 20 years now. And like Professor Simmons, I do a lot of work on a variety of different areas in AI, a lot of human AI interaction these days, and I'm excited to get to know all of you from, it looks like, all around the world.
Absolutely. Thank you, Professor Rosenthal. And as we want to help set the stage for you by giving you some more information about this larger ecosystem here at Carnegie Mellon School of Computer Science. As you can see here on your screen, and you probably know this already, Carnegie Mellon School of Computer Science is known around the world as the Center for Unparalleled Research and Education in Computer Science. It truly is a one-stop shop as you think about that cross-disciplinary approach to computer science. CMU created the first US undergraduate major in artificial intelligence. That's huge. So really an innovator at the cutting edge of this field. They are home to world-class faculty. As you'll see here today, you're going to be learning directly from faculty here at Carnegie Mellon University. And they offer both graduate and undergraduate research opportunities that are second to none. There's executive education programs designed for today's professionals, such as this one here. So if you work in a technical role or you're looking to advance into a technical leadership role, certainly coming into an executive education program like this one is a great next step. You know, SES is known as a leader in setting the course for advancements in knowledge and learning across the globe. And they do this in a cross-disciplinary way. So one of the things you'll see peppered throughout the curriculum are the ways in which we're not just looking at artificial intelligence, but we're really tying together a multitude of different disciplines here. And so we're looking through a cross-disciplinary lens. So as you think about, what is the mission? What can I expect out of my education? Carnegie Mellon is #1 in artificial intelligence specialty and graduate programs for computer science. #1 is a great place to be as you think about joining this community. What sets this program apart from other programs out there? We've called to mind here 4 different areas. And firstly, those expert instructors and faculty who are thought leaders in their fields and bringing that knowledge to all of you in a practical way. And so really not only being sort of at the forefront of advancement, but also thinking about how can I take this knowledge and make that, deliver that to others from across the globe. So really that pedagogical lens, as well as that rigorous research focus. There's an integration and an ability to develop interconnected learning modules that leverage resources from across the school. So there's that interdisciplinary, interconnected approach there. Professional roles, job sectors, years of work experience, geographies. So as you think about that peer learning, you're getting, as you're learning, you're getting the deep dive knowledge as you apply it to your work, to your career, to your organization. But in learning shoulder to shoulder with your peers, you're really getting that broadened perspective, that kind of tapestry of ideas as you see these same concepts come to life for your peers. So it really enhances your learning experience, keeps you engaged, and gives you that full scope of understanding as you see these concepts come to life in other areas. So we really believe in that peer engagement, and we've built that in, and we believe in that faculty engagement as well. So the reputation really precedes the school here. It's recognized worldwide as a leader in academic research. So you are in really good hands here at Carnegie Mellon. And as you think about who is this particular program designed for, you'll see a few pointers here on your screen. This slide here perhaps is the crux of why you're here. Is this program right for me? So we wanted to give you kind of a high level scope of understanding about who we designed the program for, but certainly as we make our way through the details here today. But as you can see, the program is really designed for anyone interested in expanding their technical understanding of artificial intelligence. There are no prerequisites required, but if you're looking to use AI principles to solve more complex problems, then this is the right program for you. We're going to be learning those tools, those techniques, methodologies, and frameworks. So if you are a software developer, a technology professional, a data science professional, or really if you're just looking to move in a cross-lateral way into more artificial intelligence systems, then this program is going to be a really great fit for you. So let's go ahead and introduce you a little bit further to your program faculty. This will give you an idea of their research area, background, and some of the themes that you'll see incorporated throughout the program here. So Professor Simmons, you met him a moment ago. He is the head of the Reliable Autonomous Systems Lab that they investigate developing reliable, highly autonomous systems, especially mobile robots that operate in rich, uncertain environments. As well as being a research professor, he served as the program director at the National Science Foundation, overseeing the National Robotics Initiatives and Smart and Autonomous Systems programs. This is huge. Really, when we say that the faculty here are at the cutting edge of their field, this is what we mean here. He's contributed to hundreds of publications related to AI and has several decades of research experience in the field. His PhD is in artificial intelligence from MIT. And he's joined here by Stephanie Rosenthal. You met her a moment ago here as well. She has many years of experience in higher education, teaching robotics, artificial intelligence, and applied data analytics. As a practitioner, she has worked in industry as well as government. So if you're thinking about, how do these programs apply to various sectors, you have an industry practitioner here at the helm of your curriculum. She's worked with organizations such as Microsoft, Intel, the Department of Defense, and robotics startup. So everything from startup to those well-established government organizations. Her research on AI and human-computer interaction are aimed to improve the decision-making and performance of intelligence systems. Her PhD is in computer science from Carnegie Mellon University. So certainly we are in good hands as we learn more about this program that you both have designed here. Professors, very, very happy to have you both with us. I'm going to go ahead and hand over the spotlight. I think we're going to start with Professor Reed.
Thanks, Marie. So why study AI? AI started almost 60 years ago. And at the time that it started, the people who started thought that it would take a couple years and they would understand everything there was to understand about human intelligence and artificial intelligence. Well, it's taken a bit longer than that. Not as long as getting to nuclear fusion, but it's taken a while. We're at a point where the technology has gotten to the point where AI is going to have and is having a very influential role in the U.S. in the world. I really like this quote by Andrew Ng, who is a prominent machine learning researcher, that AI is the new electricity. And what I infer he means by that is just like electricity today is used for everything that is technological, and we never even notice it unless it's not working. It's just there and it is improving our lives. So too will AI be there in all our technologies, improving our lives. It will help us do our jobs better. It will help us drive our cars better. It will help us be more secure, be more healthy, innovative. And AI is going to AI through some of the techniques, through the techniques that we're going to talk about during this course, is going to have that type of influence in the world. And I truly believe, and I know Stephanie agrees with me, that this is just around the corner. And you, by being involved in this inaugural course in artificial intelligence through Emeritus, will have the opportunity to participate in that new wave and be more. So again, this is a 10-week course. There's a lot of learning that's going to go on, both technical and conceptual. Some of the things we expect that you'll be able to do by the time you're finished with the course is be able to take a problem and see how it can be translated into a problem that AI can solve. And we're going to talk about various techniques. So it isn't a one-shot-fits-all. There are search techniques, there are machine learning techniques, there are optimization techniques. All of these combine together to give you a very wide variety of ways to solve problems. So you'll be able to take that problem, trying to understand how best to frame it as an AI problem, be able to analyze the problem, set it up, and be able to solve many problems. The exercises you'll be doing during the course will get you involved in the ways of how to do this. And we anticipate that you'll be able to take this back to your own companies, back to your own work, and be able to utilize them. Yes, so the program has a fair amount of math in it and Python programming. You should be familiar with both of those. There are self-assessment exercises that you should take prior to enrolling in the course to see whether you feel that you're up to speed on that. There's also ways to strengthen your knowledge if you're missing some ideas, but this kind of shows you where these tests will show you where your knowledge level should be to get the most out of this particular course. As I mentioned, it's a 10-week course. We'll be covering basically a different area each week. We set this up in what we hope is a fairly logical progression. We start with symbolic techniques, search and constraint satisfaction. We move on to probabilistic techniques, machine learning techniques, which are very much associated with statistics, randomized algorithms, which are also statistical techniques. And then we finish with some applications of artificial intelligence that are both common and up and coming, including question answering systems, recommender systems, systems that interact explicitly with people, and systems that act autonomously in the environment. So without further ado, we're going to go through each of these 10 modules, and I'll turn it over to Stephanie.
Hi, everyone. Thanks for joining. And we're very happy to be here to talk to you about this program today. The first module that we're going to talk about is search. Search underlies a lot of the techniques. It was certainly one of the first techniques that people used 60 years ago to think about AI. Search includes things like how your GPS system navigates you from your current location to a goal, where it tries to reason about the shortest path, or maybe the one that has the least traffic or the fewest left turns. There are lots of different ways that we could try to find the best path. And other ones are things like games. So Rubik's Cubes are totally in there, and little number puzzles. All of these are about how to start with some start state, and through a series of actions, take you from that start state to a goal. And so we'll talk about different ways to think about those problems, and then different algorithms that we use to get us that action plan, the plan being the sequence of act. Go to read for module number 2.
Underlying basically all of AI is this idea of representation. We represent states, we represent actions, and we have to represent them in a way that the computer can manipulate them, reason about them, act upon them, learn from them. The world is too big to represent it fully in a computer. And so when we're representing states, we're representing actions, we need to understand what are the salient points of the problem that need to be represented. So for instance, Stephanie was talking about navigation systems, and you have to know about where there are unprotected left-hand turns, where there are stop signs, what is the speed limits on various segments. You probably don't have to know who the president of the United States is, or what is the price of gold in order to do a good navigation plan. And so there's lots of things you want to include and things you want to leave out. And you want to leave things out because it just makes the problem so much harder to solve if you just put in all sorts of extraneous detail. So we're going to talk about different ways of representing the world, graph-based representations, symbolic representations. We're going to talk about heuristics. What are the rules of thumb that can be used in search that will help us solve problems easier? And this is one of the things that I think AI has really brought to the world, this idea of using heuristics in computation, things that may or may not be accurate, but help in solving problems. And by doing so, you can take essentially intractable problems and make them tractable. And finally, we'll look at one of my favorite examples called the mutilated chessboard. This is an example where a very simple change in representation takes a problem that is essentially intractable to solve to trivial to solve. And we'll see why that works and how it can be applied elsewhere. Okay, Stephanie, back to you.
Great. So the first 2 modules focus a lot on states and actions. And this module sort of changes the AI representation to thinking about how to best assign values to variables, we would call it. So if you need some problem where you're trying to figure out how many of many different things to buy, or how many to ship at your company, these sorts of problems we would call constraint satisfaction problems. So you have a set of things that you would like to solve, and a set of constraints about how you solve them. Maybe you can only buy 20 things, and you have to figure out how many apples and how many oranges to buy. Or maybe it's a shipping problem. You only have a certain number of trucks to ship things from your warehouse to your stores, and you have to figure out how you can fill up those trucks to maximize your profit. A game that you might think about is Sudoku. So in Sudoku, you have numbers that are already filled in, and then a bunch of blank squares, and you're trying to assign values between 1 and 9, such that the values 1 through 9 occur in every row, every column, and every 3x3 square. And we can solve this using search, where we start with our blank board, and we look at all of the possible ways to fill in all of those values. But heuristics really come into play here when we start to think about whether we satisfy the constraints at every level of this search. So we'll start with discrete values, real integer values of things. And then we'll think more about how we can relax this problem into continuous values. So if I can buy, I don't know, 3.8 pounds of tomatoes, how we would solve this problem using a set of linear constraints and using linear optimization techniques. What's fun about this module is that you get to sort of identify and distinguish what type of problem you're trying to solve, and then use the techniques that we provide you in order to actually find real values to each of those problems. And you can use it to solve Sudoku. One fun assignment that we have for this module is stock portfolio investment. So you can actually optimize how much stock you purchase across different types of stocks based on how much risk you're willing to take and how much profit you'd like to make. And so we'll look at really trying to apply these techniques using tools, ready-made tools for you to use to do that. Okay, back to Reed.
Thanks, Stephanie. So one of the guiding principles in AI is there's lots of uncertainty in the world, and we have to deal with this in a robust manner. Very simple example, preparing for a party outdoors. You need to know about the weather, but there's a lot of uncertainty about the weather. So what do? What kind of contingency plans might you make? Maybe you decide the weather forecast is so bad that you're just not even going to try to have it outdoors. All these things come into play when you think about what might happen in the future, where the future is fairly uncertain. And this is the realm of probability. And we have a fairly gentle introduction to probability, and then show how we can use probability to model the world using Markov processes, and using a formulation called Bayes rule. We show how we can plan for an uncertain future using Markov decision processes, which are solve sequential decision process problems. That is, problems that where decisions have to be made over and over again in time, and the reward that you get is dependent on the reward that you get over the length of time that you're executing this plan. And because of the uncertainty, you don't know what kind of reward you're going to get. And so you need to hedge your bets and think about the expected reward that you may get. And it very often we talk about rational agents in artificial intelligence. And what we mean by rational agents is usually agents that act to maximize their long-term expected reward. And this is what we'll be covering in this particular section. Okay, back to Stephanie.
Great. So it wouldn't be an AI course without machine learning. Machine learning is really changing how we interact with AI systems today, mainly because of how much data that we can collect all the time. So in Module 5, we talk about machine learning models. So the different ways to think about finding patterns in data. And those different techniques find those patterns in different ways. And so each one has benefits and costs associated with them. So we talk about when you would use them and when you might not use them. So if you see a toolkit and you're ready to use one of those as we practice through this module, you can make decisions about which types you should be using and which you don't. So it's not a shot in the dark. The ones we see here are linear regression and k-nearest neighbors, but we'll talk about support vector machines and decision trees. We'll talk about neural nets and even touch upon deep learning. So these are all really pop culture today, very popular techniques that you'll get a chance to play with and understand at a deeper level. So all of those techniques assume that you have data in a format that is clean and ready to use. And so Module 6 studies more about practically how you get to a place where you can do that. And then once you can train models, how you can ensure that you're finding the best models. So we talk about how to clean your data, how to structure your data. We talk about organizing it in different ways. And then we talk about evaluation techniques. So there are different measures of accuracy. We talk about precision and recall. And we talk about ways to split your data or divide it up so that you train your models, you build them and optimize them with one set of data, and that you're not using that same data, but you're using a holdout test set that allows you to have a less biased measure of your success of your models. And as you do that over time, we sort of get more accurate. And then all of a sudden there's sort of a turning point where with a set of test data, you might see your test error go up again. And that's because you're overfitting. So overfitting is this word that we use to talk about how we've sort of tailored our models so specifically to the data that we have and not to make it general enough for new data, that when we introduce new data, it actually does worse than we expect. We talk about ways to identify that and what to do to mitigate those risks. And so this module is really a very practical way to implement machine learning algorithms and assess how they're doing in your applications.
So one of the things we should mention about this course is that very often in the media, they make the equation between AI and machine learning, that AI is machine learning and machine learning is AI. we hope that this introduction here will get you to realize that while machine learning is an incredibly important part of artificial intelligence, it's not by far the only part of artificial intelligence. And the goal of this course is to give you a broad understanding of artificial intelligence, some machine learning, and there are other courses that go into depth of machine learning. But if you really want to understand the broader context of artificial intelligence and many of the very important tools and techniques that are used, then this is the course for you. Anyway, Module 7 is talking about what we call randomized algorithms. Now, in the first two modules, when we talk about search and heuristics, we assume that the computer, that the AI is searching the state space in a systematic way. But it turns out that many state spaces are much too large to search systematically. And in recent years, randomized ways of searching the space have turned out to be very influential and quite good. There's trade-offs. The randomized algorithms don't often find globally optimal solutions, but they usually find solutions that are good enough that they're useful, and the speed up in computation makes them the algorithms of choice. Many of you might have heard of the program AlphaGo that beat a world champion Go player in Korea a number of years ago. AlphaGo used a combination of neural networks plus randomized search called Monte Carlo tree search in order to navigate the extremely large state space of Go. I've been told that the state space of Go, which is the number of possible combinations of stones on a Go board, is larger than the number of atoms in the universe. So explicitly storing them and looking at them one by one was clearly impossible. And so you need much better techniques. We'll look at local techniques such as simulated annealing that use an approach where normally you try and head towards the better solution that's nearby, but sometimes you head to a worse solution in order to jump over local maxima. We'll look at different randomized algorithms, such as sampling algorithms, such as Metropolis Hastings and Gibbs sampling, that allow you through randomized search to generate a probability distribution where you don't actually have the underlying distribution, that you have to sample and simulate it. And finally, we'll talk about search techniques, randomized search techniques, such as Monte Carlo tree search, that allow you to very efficiently search very large state spaces and often without using heuristics, able to come up with very good answers. Again, not necessarily optimal answer, but good enough that they work very, very well in practice. And this is the type of thing that's being used not only for game playing, but also for self-driving cars are using these types of randomized search algorithms in order to make real-time decisions that, again, are quite good, even if they're not the best possible ones you could find if you had infinite time to search. We're going to look at a couple of AI applications that are in very common use today. Maybe you know that they're AI applications. Maybe you don't, but in fact, they are fundamentally AI applications, and they use many of the techniques that we've talked about in the previous 7 modules. So the first one that we'll talk about is question answering systems. The idea here is that given a very large collection of text pages, such as on the internet, how do you efficiently select ones that are most appropriate for users' search terms? We'll learn about a technique, TF-IDF, that looks at the occurrence of words in a document and the occurrence of words in all documents to come up with a measure that finds documents that have words that appear mostly in that document and not very frequently in other documents. And so these are techniques that Google uses in order to find pages for you when you put in search terms. We'll also talk about recommender systems. So these are systems that recommend restaurants and articles to buy on sites. They recommend ad placements. They recommend news that shows up on your news feed, and movies to watch. And the question is, how does it do it in ways that align to your preferences? And we'll see that there are basically two ways to do that. One, which is called content-based filtering, uses a model that the AI system learns about you personally and your preferences and tries to match your own personal preferences with items that share those features that you find appealing, and not to show things that have features that you find unappealing. The other technique, which is called collaborative filtering, uses not your own preferences directly, but uses a similarity between you and many, many other people. So the idea is that if other people share your tastes, then things that they've done that you haven't done are things that you might like to do. And so these recommender systems use large amounts of data about items and about people in order to make high quality recommendations of what you might consider doing. And you may have used these systems, and when they say people who have bought this also buy this, and you say, no, I would never buy that. Just goes to show you that recommender systems still are in need of a lot of improvement. And this is really a ongoing research problem, both at the university level and especially in commercial firms, to come up with better and better algorithms to make these recommender systems much more in line with the preferences of individual users. Okay, now I'll turn it over to Stephanie.
Great. So we have two more modules. These last couple, just like module 8, they're trying to sort of combine different techniques together. So in human AI interaction, we cover techniques that help you interact, as it says, with AI systems. So dialogue systems, maybe like Amazon Alexa or Apple Siri and others. How do they work? A lot of them are using techniques that we've already talked about in the class. So they're searching, or they're using TF-IDF or other information retrieval techniques to find the right answers or the right information for you when you ask them questions. And then we sort of turn it around and think about AI and ethics. So how do I make sure that my AI system is acting in a way that I think is ethical and unbiased, that I ensure that it's not going to hurt somebody when I deploy it, and that it's trying to make good decisions, but also ones that are reasonable in some way. So we outline not only the challenges in interaction with people, but also the challenges with with thinking about ethics and ethical decision making. How do you make systems fair or transparent or explainable? How do people understand what these systems are doing and how they affect people's daily lives? Some famous examples from the last 5 or 10 years include things like AI systems that decide whether you can get a mortgage. And it has been the case that a lot of these systems may accept or reject you without an explanation, and there's maybe nothing that you could feel that you could do about that decision. So how do we build these AI systems so that they can give you more information and you can understand the decision that was made? We could think about it for self-driving cars. What decision is it going to make, and how do I know that it's going to be safe or trustworthy? So those are the types of interactions that we're going to talk about in Module 9, and Reed covers the last one.
So the very last section we'll talk about is how to put it all together to make an AI agent that can act autonomously in the real world. And examples include things like self-driving cars, Mars rovers, deep undersea vehicles, vacuuming and lawn mowing robots, hotel delivery robots. Many of these are, prime examples of autonomous AI systems where the system has to get sensor information in from the world. It has to manipulate that sensor data through perception algorithms. And there's a course in computer vision that, if you're interested in the perception aspects, would give you a good leg up on how to do some of those things. Then based on the perception, the system will think about what needs to be done, plan it out, take actions, learn from its experience to improve the perception, cognition, and action aspects of it. And then when it acts in the world, it changes the world, gets new sensor information, and that repeats over and over and over again. The course that we're talking about focuses mostly on the middle two boxes, the cognition and the learning boxes. But we will talk in this module about how they connect to the rest of the system in order to make an autonomous agent, as I said, that can be safe and reliable, working in the world, or working with people. So if I have an assistive robot that is helping in a hospital, it not only has to act autonomously when it's going through the hallway environment, but it also has to act autonomously, but in a natural way when it's interacting with doctors and patients. So hopefully by the time we get through all these 10 modules, you have a much better idea of what artificial intelligence can do. You'll have a lot of practice with AI algorithms and taking quizzes and doing activities. And hopefully you'll be able to see how the AI fits into your own work and environment and interest. So that will turn it back to Marie.
Thank you to both of our professors for being here with us and taking us through this curriculum and kind of providing that layer beneath the surface understanding about this program and the types of learning that will be taking place over the course of these 10 weeks. So a lot in store here as you think about diving into this program. But as we make our way through the program experience portion of our time together, this will give you that sense that, what are the tactical components of this program? What is that day-to-day experience like? And as you can see here, there's a lot of different activities and engagement points throughout your 10 weeks here in the program. The first thing to note is that we start off with what we call week 0. That gives you a whole week of orientation. So you'll have an opportunity to get to know your learning platform, get to know your peers, get to know your instructors and colleagues, get to know the program material and some of those course policy details. You might be wondering, what's the course schedule? what is the assessment criteria for the program. All of that will be contained within that orientation week. So you'll have that opportunity to really get oriented before you dive in. From there, you can see here on your screen, there's a variety of different activities. And what we've done here is we've blended together synchronous as well as asynchronous components. So some of this is happening live, such as today's session, and other parts are asynchronous, allowing you that on-demand convenience of being able to watch video lectures over and over around a schedule that works for you. So we call this approach, this sort of synchronous, asynchronous approach to online learning. We call this bite-sized learning. So what you'll do is you'll watch a set of instructional videos. Again, these are on demand. From there, you'll step away and you'll take part in a variety of different activities, many of which are asynchronous, allowing you to touch in on your own schedule. You'll see some of them listed here. There are programming assignments, case study analysis. There are crowdsourcing activities and wikis, scenario and problem-based learning, knowledge checks. This is all taking place throughout your time in the program. Discussion boards. These are all asynchronous, meaning that you're going to be touching in on these around a schedule that works for you. There's also these live teaching sessions. You'll see there are office hours with learning facilitators. So as you think about your the various community involved here in this program, we talked about this broader community here at Carnegie Mellon University School of Computer Science. You've met your program faculty, sort of a layer in there. We've talked about your peers. You have yourself at the center, but there's two other components here, two other layers of teaching and learning taking place. And one of those layers is your learning facilitators. And I want to draw your attention to this one in particular, because it's perhaps one of the most critical components of this program is a chance to have a dedicated learning facilitator at the helm of your day-to-day experience. The learning facilitators are industry experts. They're often alum of this program, alum of Carnegie Mellon University, and they come into this program to help guide your day-to-day experience. So they're hosting office hours. Those are live learning sessions where you can turn on your audio, your visual, engage live with your teaching team. Your learning facilitators can answer your questions. If you'd like additional resources or help, they're right there to help you with anything that you need throughout your time in the program. And they're giving you individualized feedback on all of your assignments. So when you submit an assignment, you're getting that customized feedback from your learning facilitator. It's not just simply submitted for completion. So you have that rich interactive learning and teaching happening through that relationship with your learning facilitator. And then second to that, you also have a dedicated program support team. This is a 24/7 program support team available around the clock for any of the help or support that you need throughout your time in the program. We're actually joined here today live by our program support team. We have Sneha with us hosting the session, and we also have our academic advisor with us, Naren. I'm going to be giving you some more information here in just a moment on how to get connected with Naren for next steps on this program. But certainly a lot of opportunity for you to build relationships, expand your professional network, and really gain a full scope of understanding as you learn not only from an individual perspective, but also as you learn across these various layers of teaching and learning from your peers, your learning facilitators, your faculty. All of this culminates in a chance for you to earn a credential, a certificate of completion here from Carnegie Mellon University. And you'll see on your screen as an example of what that certificate might look like. And this really formalizes your training and helps to showcase your learning and experience here in this area of artificial intelligence. So a big return on your investment here is broadening out your professional network, gaining peers and colleagues from across the globe. And you also have a chance to earn this credential here. So certainly for those of you looking to springboard into career advancement opportunities, having a certification here from Carnegie Mellon is going to go a long way in helping you to reach those goals. There are also opportunities for you to take other programs. We've got a listing of other programs within the portfolio here across different computer science disciplines. So we encourage you to take a look at some of our other offerings as well. And then finally, for corporate customers, one big advantage is coming in with a group. in order to learn together. So as you're thinking about expanding within your organization, we have various discounts and so forth available for those of you coming in together with team members within your organization. So you'll get a dedicated learning facilitator tailored to meet the needs of you and your team, as well as special group enrollment pricing. So some opportunity there as well. This is our last and final slide here of the day before we close out the session. And this is where I tell you all about how to get connected with an academic advisor. If you open up your chat box, you'll see that we've posted a link there for you in your chat. If you click on the link there, it'll take you over to the course enrollment page, which looks very similar to what you see here on your screen. If you click on that black Apply Now button, that will do two things. Firstly, it'll invite you to put in your contact details so that we know you're interested in the program. And the second thing it'll do is invite you to schedule a one-on-one appointment with our academic advisor for this program, the foremost expert when it comes to all of the logistics for this program. If you're interested in dates, if you're looking to learn more about when those live sessions are scheduled, there's also the course policy details. Perhaps you're wondering, what is the evaluative criteria for the program? How do I earn that certificate of completion? Your academic advisor will be able to help with that. And then certainly the stage we're all at now, that registration and enrollment, getting those application materials together and exploring various financing options, having an advisor is going to be a crucial next step for you. You can see here there are discounts, early bird benefits, special group enrollment pricing, flexible payment options, a lot to sort through here. So as we talk about this program, we talk a lot about the relationships that you'll build with your learning facilitators, your faculty, and so forth. And we want to make sure that that high level of support and relationship building begins right here, right now with today's session and getting connected with an academic advisor. So certainly use that link there in your chat box to go on over to the course enrollment page. Marin is here with us and waiting to hear from you as well. I'm eager to schedule that one-on-one academic advising session. If you prefer to connect over email, we've also provided for you an email address in the chat that's cmuscs@emeritus.org. You're welcome to connect there as well. And finally, as we've mentioned a couple of times here, we have recorded today's session. The next thing we'll be doing is sending you copies of the recording as well as all of the slides here today. And certainly by then, if you don't yet have an advisor, you can reply all to that email and let us know. We want to make sure that you have all of the help and support that you need. So with that, I see we've done a really good job of answering your questions throughout here. We don't have anything pending, but we are reaching the top of the hour here. So I want to invite our professors back into the session here for any closing remarks, words of wisdom, advice, as we say goodbye to participants here. So maybe we'll start with Professor Simmons. Any final words of wisdom you'd like to leave us with here today?
I'll just repeat what I said before, that the thought is AI is going to be the new electricity. This is the wave of the future. This is where it's going. If you're in a technical field and want to, ride the wave, this is the place. This is the way to do it.
Certainly, there's never been a better time to be on the cutting edge here. The landscape is changing, certainly. And I love that quote too. Professor Rosenthal, any final words that you'd like to leave us with as well?
Reed and I have worked really hard on this course, thinking about ways to structure the material to make it relevant for a lot of different fields and interesting and exciting to think about. And we would really love to have you in this course this run. Thank you very much.
Thank you as well, Professor Rosenthal, and to all of you who've joined in from across the globe. Thank you for being here. It's been an absolute honor and pleasure learning shoulder to shoulder with each and every one of you over the course of this last hour. We hope to have you back in the program, but for now, we will sign off today's session with a heartfelt good morning, good afternoon, good evening, and good day to all of you from around the globe. Thanks again for joining, and we hope to see you back soon. Bye-bye.